Hey everybody, the purpose of this video is to get you some solutions to the normal quiz. It's pretty straightforward. It's one of the easier quizzes I'm sure you realized of the terms, because there's not much to it really. It's a matter of just interpreting what I'm asking you to do symbolically and be able to run through technology to figure out your areas and reverse z-scores. So they're all, I picked the ones I picked. The quiz is really intended for those going on to do 244, because these numbers that you see up here are pretty prevalent in, well, at least the first three are pretty prevalent in inferential statistics. This guy here, I was asking, what's the chance that you land on a z-score that's above 1.96? Now, we've been using the number 2 quite a bit in class. 2 is what 1.96 rounds to. And the reason we like 2 is because 2 standard deviations represents roughly 95% of your data, which means that area right there represents roughly half of that, which would be 2.5% of your data. And now the point of this, too, is not for you to know that off the top of your head. I mean, maybe you do at this point. Some of you do, I know, because I asked you in class. But a bunch of you are just going to run right to your TI and call that a forwards, right, left-bound 1.96 problem. That's exactly what it is. It cuts off 2.5% of your data. So that's all I need you to do there. Less than negative 1.645 is the same exact deal. This number won't ring a bell as much as 1.645. This one won't ring a bell as much as this guy, and that's okay. That's totally fine. It's somewhere between -2 and -1. It's about halfway between. And again, that's not going to tell you a great deal, because you can't divide the areas by 2 because they're not linear. But this represents the cutoff for 5% in the tail. So if you were to cut off positive 1.645, so 1.645 standard deviations is the cutoff for the middle 90% of the data. More on that in 244 if you go down that journey, if you take that journey with us. This is another one that's fairly unique to an inferential stat course. If you go all the way out to negative 2.575 and up to positive 2.575, you've actually shaded about 99% of the data. So these are all the forwards problems from your quiz. That's a forwards right 1.96. Here's a forwards left negative 1.645, and here is a forwards between negative 2.575, positive 2.575. This is probably the most important for 244ers, because that's one of the first things we do in 244 is start knocking down the idea of a confidence interval. Okay, so these two over here, the 75th percentile and 40th percentile, that's what, hopefully you recognize those as percentiles. You kind of know the answer to this one already, especially if you're doing the last exam. 75th percentile is going to be the z-score that traps 75% of your data. So it's backwards because you have the area and you need the z-score to do it. So you know that 50%, thank you Austin, 50% of the data is shaded from 0 down, which means this guy's 25% of your data right here. And we've talked about this a number of times since like week 3 or week 4. That means this, now you don't have to know this, but this guy has to be 2/3, or as a fraction, or as a decimal, 0.67, 67 hundredths. You don't have to know that right now, of course. It's a backwards, shade left, area 0.75 problem. That'll give you your 0.67. It's two-thirds of a standard deviation. 2/3 of a standard deviation captures the middle 50% of your data. So if you put the line in the sand here, there's 25%, there's 25%, and here's your leftmost 25%. So that's all that is. And this is the same thing, but it's on the left side of the curve, 40th percentile. So you're going to chuck that guy right there. And I think I even drew that kind of wrong. It's actually a lot closer. There's a lot of area right in here. That would be 10% of the area. And I think this one's negative 0.25 for an area of 40%. I'm pretty sure for an area of 40%. That's going to be a z-score of negative 0.25. Just one final caution. These are not percentages. They're numbers of standard deviations. I know they look like percentages because they're decimals, but that's just because they're decimals. They're not whole numbers. So these things down here are unitless numbers of standard deviations. The percentages exist in how much of the curve you're shading. So I hope that helped. It was a pretty straightforward quiz. Sorry it wasn't more engaging and challenging. The binomial quiz took care of that. I hope it helped, and we'll catch you soon.